Okay, 1.4, this is day 2. We are now moving on to the Pythagorean identities. You should all by now be able to round off the reciprocal identities. What were the reciprocal identities?
Oh, you know.
What were they? Sine equals
Cosecant.
1 over cosecant. Cosecant equals 1 over sine. Cosine equals 1 over secant. Secant equals 1 over. Tangent equals 1 over. Cotangent equals 1 over. Okay, and what were the ratio ones? Tangent equals what over what?
Sine over cosine.
Okay, and cotangent equals?
Oh.
No, well, yeah, but cosine over sine, the reciprocal.
Oh.
So the ratios. Okay, so, like I said, this first chapter is, I'm not over exaggerating, it is used every day throughout the entire book. Okay, so the next thing we're going to work with are the Pythagorean identities. So we talked about how the Pythagorean theorem, which is a squared plus b squared equals c squared. Yes? We talked about that is the same as the equation of a circle, that is x squared plus y squared equals r squared. Remember talking about that? How when we have a circle, and we want the radius of that circle, we can make this triangle. And so we have x and y. So that's the same as a squared plus b squared equals c squared. We've talked about that. That's the same as the distance formula, correct? So those are all the same. You know, when I was in school, I wish somebody would have just said they're all the same thing. Because they are. And because I always thought the distance formula was absolutely the worst thing in the world to remember. And it's really not. It's just the change into the x's and the change in the y that tells you the leg, the x and the y leg. So if I wanted to solve x squared plus y squared equals r squared for, well, we won't solve it for. We're going to make r 1. How would I make r squared 1? I want to make it 1 first.
Make it 1.
Make it 1.
R
Zero
equals
power.
1.
0 power, yes, but like, remember when I have an equation, whatever I do out on one side, I have to do the other side. So I can't, because then the other side would equal 1 too, and that wouldn't do anything. It would say, actually, if we got it to the 0 power, so took it minus 2, minus 2, minus 2, we can't, actually, we're not doing the same thing, because this would be dividing by r, this would be divided by y, this would be, so it wouldn't, kind of that, but not exactly how you're doing it. So divide everything by r what? Squared. Okay, so if I divide everything by r squared, which is kind of what you were saying to do, but not quite the same way, right? R squared over r squared is 1. And then we have x over r squared plus y over r squared. Just how we can distribute the 2 in, we can also factor the 2 out, can't we? Okay, because sometimes it's easier to do the division, then square it before you square it and then divide. What is x over r?
Cosine.
Yes. So it's cosine squared. And what's y over r?
Sine.
Sine squared. So we just made the first Pythagorean identity. Cosine squared plus sine squared equals 1. Can I say sine squared plus cosine squared equals 1? Why not?
Yeah.
I don't know.
It's addition. Can I move it around any way I want? Yeah. So it's addition. I can move it around any way I want. How else could I use that formula? Could I rearrange it? Could I solve just for cosine using that? If If I just wanted that to be cosine equals, what would I do?
Minus the sine squared.
So I'd minus the sine squared over and then take the square root.
Yeah.
So cosine of theta would equal plus or minus, because I'm taking the what? Square root of 1 minus sine squared of theta. Now, I have a question for you. If you saw sine squared minus 1, would that be equal to cosine squared? If you saw in a paper sine squared minus 1.
No.
Why?
Because you can't do the same thing with minus. You can't with addition.
You can't do the same thing with subtraction that you can do with addition. Now, if I moved it around, it would be like this, correct? But could I do this?
You can't see that.
Oh, thank you. Can I factor out the negative?
No.
I can't switch it around and then factor out the negative?
Yeah.
Yeah, I can.
Switch it around.
And it wouldn't be positive cosine squared, it would be what? Negative cosine squared. So can I do a lot with this? The same thing I just did with cosine, can I do it all with sine? So sine would be what? Plus or minus what?
Square root
Of
1 minus cosine squared.
1 minus cosine squared. Now, if you look in the book, if you had you looked at the book, they would give you the Pythagorean identity and they would say, there's 16 combinations. But the only thing I really need to remember is what? That one. And the rest of it's just algebra and me moving it around and manipulating it, isn't it? Okay, so we will see cosine squared plus sine squared equals 1 in many different forms. Now, those are squared, yes? Does cosine plus sine equal 1?
No.
No. It does not. Does not equal 1 because they're not what?
Squared.
They're not squared. So let's say if I had 30 degrees. Okay, so 30, 60, 90 triangle. We're going to do this real quick. What's opposite of 30 degrees? What's the ratio opposite of 30? You guys remember? It's 1. Opposite 60 is square root of 3. And then 2. Or, yeah, we're just going to leave the 2's. So this is my x, and this is my y, correct? Because this is the x-axis, and this is the y-axis. Yeah? Okay, so cosine of 30. We're going to prove it to ourselves. Plus the sine of 30, because I said theta, so it has to be the same angle, right? Equals 1. So what's the cosine of 30? Square root of 3 over 2? X over y, or r. So square root of 3 over 2. Plus, what's the sine of 30? Opposite over hypotenuse? Or opposite over r. I've got geometry in my head right now, and we're doing opposite, adjacent, and hypotenuse, and you guys are still in x's and r's. Sorry. Is it bothering you that I'm doing opposite, adjacent, hypotenuse? Is that messing you up?
Yeah.
Okay. So it's y over r. So it's 1/2. Can I add square root of 3 and 1 together? Can I add those two together? No, because it's a radical, right? So I have 1 plus the square root of 3, 1 plus the square root of 3 over 2. Does that equal 1?
No.
That does not equal 1. But what happens if I go and I square it now? Well, if I squared this, I would get 3 over 4, wouldn't I?
Mm-hmm.
If I squared this, I would get 1/4.
Mm-hmm.
What's 3 over 4 plus 1/4?
1.
So do they have to be squared to be equal?
Yeah.
Yes. Okay, I'm just bringing up mistakes that people tend to make. Okay, if they are not squared, there better be a square root involved to take that square away. Do you have hearts on your nails?
Yeah.
What?
Yeah.
Yeah. Oh, cute. Okay, so that's the first Pythagorean identity. Now I'm going to go back with x squared plus y squared equals r squared again. So we made r1, didn't we? How about we make x1? How would we make x1? Divide everything by
X squared.
x squared. So I have 1 plus y over x squared equals r over x squared. Well, what's y over x? So I have 1 plus tangent squared of theta. And what's r over x?
Secant.
Yes. So secant squared. Good job. So my next Pythagorean identity is 1 plus tangent squared equals secant squared. You guys are deriving identities right now. You're making them. You're manipulating a formula to make an identity. Now, how am I going to remember that tangent and secant are the ones that go in this? What's in the denominator of tangent? X. What's in the denominator of secant? X. So that's how we're going to remember it's tangent secant. Now, can I move the tangent over and take the square root and make it equal to 1? Yeah. Could I take the square root of this and get secant? Could I subtract the 1, take the square root, and get tangent? So I can do all that manipulation. Okay, and I reminded you guys it was plus and minus. How do I decide the plus and minus? Which what? Quadrant? Okay, so you pick the plus or minus depending on what quadrant you're in. Okay, so one more. What's the only thing we haven't made? One.
Cotangent.
Well, x, y, or r. It's the only
Y.
y. So we're going to divide everything by
Y squared.
y squared. So that gives me x over y squared plus 1 equals r over y squared. Well, what's x over y?
Cotangent.
Yeah, cotangent. So cotangent squared of theta plus 1. And what's r over y? Cosecant. And there's the last. Now, I typically write it 1 plus cotangent squared. Just because this one's like that. Can I do that?
Yeah.
Why?
That's just addition.
It's just addition. I can write it either way I want, right? And again, can I manipulate it and all sorts of things and make it fun? So we learned that sine squared plus cosine squared is 1. But if I subtracted the tangent, we also know that secant squared minus tangent squared equals 1. Correct? And then we also know that cosecant squared minus cotangent squared equals 1. Does 1, can I make many things equal 1? Have I always been able? 7 minus 7 is, or 7 minus 7 is 0. 7 minus 6 is 1. 5 minus 4 is 1. So there's lots of ways to make 1. And when we are proving identities, that might come in handy if I can make things 1, because when things are 1, does it make it easier to deal with?
Mm-hmm.
Yes. So there are 3 Pythagorean identities. You need to know all of your identities. You need to know the reciprocal, the ratio, and the Pythagorean. Which one is going to be the hardest to remember? The Pythagorean. You think the ratios are going to be harder to remember?
Yeah.
Really? Sine over cosine, cosine over sine? I'm going to tell you that anytime you see squared functions laying around, you need to start thinking Pythagorean, how can I make it fit? Now, can you always make it fit? No. But if I can make that fit and I can make it equal 1, can that make my life a lot easier? Yes. So, what we're doing today is everything you do, you're going to be finding all 6 trig functions only using the identities. So, would you like to in one place write all of our identities so you
I
have
did.
them? You did? Good.
What do you mean?
Like, in one place, he wrote his reciprocal, his ratio, and his Pythagorean.
I wrote them all here.
Oh.
No, like in
I wrote all
one,
the
like,
identities in one place.
what?
Chunk?
I wrote all the identities in one place.
That's what I
Let's
just
do
I
said.
wrote identities.
Oh, the Pythagorean identities? Okay, let's just do them all in one place so we have them. Okay? So they're at the end of the notes. You can box them, you can highlight them, whatever you want to do with them. Your notes are a guide, they're not a crutch. So when you're doing your assignment, you need to try to remember without looking every time. Does that make sense? Because if you're looking every time, are you learning them? No. Okay, so we're going to start off with the reciprocal. And I would assume we're like pretty good, solid on those. I don't know. Maybe not. Maybe I shouldn't make an assumption. Okay, how do you guys want to start? Do you want to start with like secant, cosecant, and cotangent and go that way? Or do you want to start with sine, cosine, and tangent? Ooh, that did not
And go
focus.
sine, cosine, tangent.
Yeah,
Okay.
sine, cosine, tangent.
So sine of theta, evidently sine is spelled with an O now. Sine of theta is equal to 1 over what function?
Cosine.
Cosecant.
Oh, right.
Yes?
I was thinking of it wrong.
Yep. Okay, and then we're going to come right next to it and say cosecant of theta is equal to 1 over what function? Sine of theta.
You think? Of theta.
Of theta.
Oh, I thought you said I think.
Oh,
I
no.
was like, what?
No, I'm pretty sure. So cosine of theta is 1 over what?
Secant.
Secant of theta. And secant of theta is 1 over cosine of theta. I was hoping to get these all on one. Can I put the tangent and cotangent over here? Is that going to bother you? Okay. I want to get them all on one screen. Okay, so cotangent. No, how about tangent first? Huh? Tangent is 1 over what? Tangent of theta, I moved it, is 1 over cotangent of theta. Let's just write our ratio ones right next to it. Which is also equal to what? Whatever what? What function over what function is tangent also equal to?
Wait, why are we writing them next to each other?
Because it's all equal. They're all like it's I want you to see that it's 1 over cotangent, but it's also whatever what. Sine.
I don't have space.
Where were you writing it?
I don't have space
Oh, because you already wrote them? Well, you can write it underneath. I'm just going to write it there.
Okay.
Okay. So, tangent is also equal to whatever what?
Sine over cosine.
Sine over cosine.
Um,
See, Olive, I just wanted you to see that.
what are
Yeah.
these ones called?
This is a ratio
Okay.
identity.
Are we gonna write the ratios separately?
Do you guys want them written separately?
Yeah.
I'm just gonna do it.
Okay. I just wanted you to see how they're all equal. Does that make sense?
Mm-hmm.
It's a good idea. I just don't have space.
Okay. You do whatever you want. Okay. Cotangent of theta. The reciprocal is 1 over
Tangent.
tangent of theta. And the ratio is what?
Cosine.
Cosine over sine. So what it needs to come down to when you look at these things, when you see cotangent, soon, very soon, you should see 1 over tangent, cosine over sine. Like that's what you should see there.
Wait.
What?
Tangent and cotangent are the laws of the ratio.
This is the reciprocal.
I know, are they the laws of the ratio?
Yes, those are the only two for the ratios. That's
Oh.
why I was doing them the way I did.
Okay, that makes sense. 'Cause I
Okay. Yes. I was like, why are you guys having such a hard time with this? Now I know why. You thought there were more. The ratio only sign tangent and cotangent. Okay? And then the one we did today is what?
Pythagorean.
Pythagorean. Oops. And why is it called the Pythagorean identity?
Because it comes from the Pythagorean.
It's derived or comes from the Pythagorean identity. I mean, not identity, theorem. It's not, I just write too big. Okay, so what's the first one?
Cosine squared of theta plus sine squared of theta equals 1.
And the next one?
1 plus tangent squared of theta equals secant squared of theta.
And let's do 1 plus. And then 1 plus.
Cotangent squared of theta. And it equals cosecant squared of theta.
And how are we going to remember it's tangent and secant and cotangent and cosecant?
Because they have the same denominators.
They have the same denominators. Are there ways, can you think of a way like I could trick you thinking it's a Pythagorean identity and it not be? What could I do with this, with the same three things, and trick you?
Take the square out.
Take the squared out. Okay. What's another way?
Have it plus 2, maybe? Or do cotangent squared of theta plus cosecant squared of theta equals 1?
Yeah, do the plus because it would be a minus, right? What if I did like 1 plus cosecant squared equaled cotangent squared? Would that work? No, it wouldn't. That wouldn't work, would it? So when we do this, we have to know our algebra properties of what we can do moving it around back and forth, right? So if you think it might work, do it over to the side and say, okay, can I manipulate this? But don't just assume, okay? So how this is going to work today is they are going to give you one value. They are going to say sine of theta equals 3/5. And have you already noticed they write their fractions next to each other? And it really bugs me, at least. They write it like, don't do that. We do so much fractional math, you need to keep them like a fraction. Does that make sense? Okay. And theta terminates. What does that mean? Terminates.
It's the
Where it stops, right? So I'm going to say instead of theta terminates, I'm going to say theta lies in quadrant 2. Now, they could also say that sine is positive and cosine is negative. Well, that would be second quadrant, right? Those would be clues to get you the second quadrant. So, and then it's going to say find cosine and tangent using identities. You are not allowed to make a triangle and use Pythagorean theorem today.
rude.
Okay? If you want to use a Pythagorean, it needs to be an identity. Got me? Okay. So, I'm just going to change it so we can maybe just do one example. They would say the remaining trig identities. So I gave you one. How many more do you need to find? 5. Okay? So I always start with sine of theta equals 3/5. Well, where can I go immediately from sine of theta to what?
Cosecant.
Cosecant. So what you're going to do is you're going to write cosecant of theta equals 1 over sine of theta. So we're learning our identities and then reciprocate it, and the answer would be what? 5/3. So we're going to write the identity before we use it. And you all know the purpose of that, right? So you can get it further back in your, not just in your frontal lobe, you got a long-term memory. Okay, so what function do you want to go to next? Because we have sine and cosecant, and we have these identities are all we can use.
I thought we were just supposed to use Pythagorean.
No, you can use the Pythagorean identities, you can use the reciprocal identities, and you can use the ratio identities, but you can't use the Pythagorean theorem. You can't do a squared plus b squared equals c squared. So what function do you want to go to next? Because we still have cosine, secant, tangent, cotangent. So I can't keep my identity. So look at your identity list, and you have sine and cosecant right now. What?
We could do,
Cosecant and secant.
yeah, we could do the Pythagorean identity, cosine, and sine equals 1.
Right. Couldn't we use
And
cosine and
find
sine equals
cosine.
1?
And find cosine.
And fine. Can we do that?
Yeah.
Okay, so if I want to use the Pythagorean, so I'd have to subtract over sine and take the square root. Yes? Okay, so cosine of theta equals plus or minus the square root of 1 minus sine of theta. Okay, so we are in the second quadrant, so is it plus or minus? Decide that first.
For what?
We are in the second quadrant, so is cosine positive or negative?
Second,
We're in the second quadrant. Cosine is what variable?
negative,
Why?
because it's x.
It's x, and x is negative in the second quadrant. Okay, do you see how you have to run back through everything we've done? So decide your positive negative first, because if you don't, you're going to forget about it. Okay? So it's going to be negative. So we have negative the square root of 1. Oop, I forgot my squared on my sign. You guys didn't call me out on that. 1 minus, well, what is sine?
3/5.
3/5. So 3/5 squared. Okay, so 3/5 is 9 25ths.
Mm-hmm.
And so 1 is 25 over 25.
Yeah.
So 25 minus 9 is 16. I was like, you guys have done that a million times in your homework in the last week. Oh, you need to tell me to move down. Because so I have 16 over 25. So what is the square root of 16 over 25?
What? 4/5.
4/5. So negative 4/5. I went sideways just because I want to have room on the rest of my paper. So do you see how we're going to only use identities? So did we really use the Pythagorean theorem, though, right here? Yes, we did.
It was 9. It was 1.
1. Have to get common denominators, so this is 25 over 25. So 25 minus 9. Okay. So now I have cosine. What's my next thing? What's the next just automatically? If I have cosine, I should find what? Secant. Because they're reciprocals, right? So secant of theta equals 1 over cosine of theta, which equals
Negative 5/4.
-5/4. So now what are we down to? Cotangent and tangent. I'd assume we'd find tangent first, but you guys decide.
We can.
How do you want to find it?
Pythagorean identity.
You guys want to use the Pythagorean identity?
How else
Well,
would we do it?
tangent of theta equals sine of theta.
Oh, yeah, we'll
equals
do
sine.
that.
Yeah.
That's easy.
Can I do Pythagorean identity? Oh yeah, I can. But isn't it easier just to do sine of theta over cosine of theta?
I kinda forgot about
Yeah.
I like cotangent as well.
So tangent of theta equals sine of theta over cosine of theta. I was hoping you guys would let me do the Pythagorean. So what is the sine of theta?
3/5.
3/5. And what is the cosine of theta?
-4.
-4/5. Now, when I divide fractions, I multiply by the reciprocal, yes? And we've talked about this before. If the denominators are the same, the denominators are going to always do what? Reduce out.
Mhm.
And the answer is going to be negative
3/4.
3/4.
And then cotangent is the reciprocal.
So cotangent of theta equals 1 over tangent of theta. So it is negative
4/3.
4/3. So a quick check, we're in the second quadrant, so that means the only thing that's positive is sine and its reciprocal, correct?
Yep.
So is that the only thing that's positive is sine and its reciprocal on your paper? Now, the only time we had to clearly make that decision was when?
At the beginning.
At cosine, correct?
Mhm.
Did everything else just fall into place?
Mhm.
Yes. So our negatives and positives important.
Mhm.
And they're all decided by x's and y's. And y's are what function? What function is y?
Tangent.
No. Sine.
What did you say?
What function is y? Sine.
Oh,
What function is x?
cosine.
Cosine. When you hear sine, you should y. Cosine is x. Because that is only what decides the positive and negative, right? So we need to start. And I will, when I teach you something, guys, I'm like, okay, what do we know here? And here, and here. We're backtracking, right? I don't want us to remember everything. I want us to remember the thing we're at because we know this. And does that make sense? I'm trying to link it. I don't want to have everything in like random access memory. We need to link back to permanent memory. Okay, do you want to go through another one?
No.
Okay, does it take a minute?
Yeah.
Okay, will it go faster after you start going?
Jeez, Miss Smith.
No, it's written that way because there aren't that many problems. Because if I just did odd, you'd have more problems. Does that make sense? Like I picked problems.
17.
Okay, but
That's alright.
if I did 27 through 57 odd, how many would you have?
I don't know.
On Valentine's Day.
Yes. Yes. Oh, I should have made it 14. You guys are silly.